So what exactly mean by a configuration management? What do you mean by a configuration from any system perspective? Can you give any example?
So to set up any tools for their need.
Yeah. So from a system administrative perspective, I mean, but for example, you take your laptop, right? You create a user, that's a configuration. You enable a service, that's a configuration. You disable a service, that's a configuration. You install a software, that is a configuration. You uninstall a software, that is a configuration. You change the port number, you disable port number, you enable port number, whatever that changes the state of the system from current state to another state, then that we call it as a configuration item. Right? By changing it, the system behavior will change, or the state of the system will change from one state to another state. Right? That could be creating a file, but if you read a file, right, will the state of the system changes? No, right? So you are just reading some info. The state of the system changes? No. Correct?
Yeah.
If you create a file, you create a user, you delete a user, then you are going to change the state of the system, right? So that's what we call it as a configuration. So any item which can be changed, right? So that we call it as a configuration item from a system perspective. So the example, they are also called as a resources. For example, right, a software, a service, a file, a user, a permission, right? So these all are, we call it as a configuration items, right? So if any, for any system administrator, these are very basic things, and these are the day-to-day operations what they will do. Okay, if you take any operations engineer, what is their duty? So they need to make sure the system is always up and running. But in order to do that one, so they need to do a lot of configuration changes, right? So if something goes wrong, again they'll go and restore. And if the log file is full, the system memory is completely going to full, right? Then they need to go and delete the old logs. And if the service is down, they need to go and start the service, right? If some port number is blocked, and they need to go and enable, or if some user is trying to access from outside and is not authorized, and they need to block them. So like that, there are so many system administrative activities, right? That is their data. So how they are going to do? There are so many ways. They can log into system and they can do it manually. For example, you are delivering a software. Forget about all about these things. You are delivering a software which you may need to install on hundreds of systems. For example, there is a patch, right? Security patch, and you have hundreds of computers in your organization. Some security patch rollout. So, for example, recently there is a Log4j attack where attackers can, outsiders can, hackers can attack your systems because of the bug in Log4j. What a company has to do immediately? They have to take that necessary actions to mitigate that bug, right? So they need to roll out a new version, new security patch, and you have thousands of systems, right? Then how they have to do? So each, administrator has to log into each and every server, manually download that file and install on that specific server. So how many engineers you need, or how many one engineer can do in within how many days? So those are the things, if the problems if you do it them manually. But if you have an automation tool where all these hundreds of servers, thousands of servers, only one system can from one place within a minute or two, if it finishes, how much cost you are going to save, how much time you are going to save, how easy it is to manage, right? So that's where this configuration management tools comes. So if you have to roll out a particular software, or if you have to configure a specific change to a specific machine, or you have various combinations, you need to install Java on one computer, you need to install Jenkins on another computer, you need to install JFrog on another computer, Git on another computer, like this. You have various combinations, right? And all these things, generally in a traditional way, you people have to, now we have done, right? We have logged into that system. We have followed some installation steps so that we verify at the end that software is installed or not. But if this has to be done on thousands of computers, you are going to waste lot of time and it is very costlier process. In order to achieve, make it simpler, we have this configuration tools comes into picture, which will solve the large scale deployments, right, within a less time. Understood?
Yes.
Yeah.
So from one single centralized server, you can manage the entire infrastructure, right? Entire computers in your organization. So what are the popular configuration management tools we have nowadays? We have Chef, Puppet, SaltStack, and Ansible. Okay, but I said we are going to learn Ansible. They all are similar. Okay, there are few differences. The language in which they develop is different, but the ultimate goal is they all solve the same problem. Which one you wanted to choose is the organization's choice. Okay, just for the understanding, I'll no just discuss the at high level, but in detail we'll learn only Ansible. So what are the purpose of any configuration management tool? So I have some points. It helps to manage software configurations effectively. It helps to remove the manual errors because everything we are going through a software or a programming language. So if you are doing any manual errors, that will be eliminated. So if you have multiple environments, right? So it will help you to manage those multiple environments, huge number of systems, multiple environments, right? And so you can also version control this, right? What do you mean by version control? Somebody has done some change today, and another day some other person came and again he has done change. You don't have a record of these things. Who changed what? So now, but with this thing, everything, whatever the change that you are going to do, this is a program, programmatically, right? You write a program, you save it in your version control system, so that you are who has changed this thing. Similarly, how development code is written. So this one also you can version control, so that if some change is going to be applied, then you can maintain in that version control system, so that you will have a record of this thing. Who has done what change? Someone has gone and changed the port number from 8082 to some 9999, and you are trying to access on 8080, but it is not working. You wanted to know who has changed and to what value it has changed. You can go and see in the version control system. Okay, some person has changed the port number from 8080 to 9999, and he will have some data. So that's where you can go and find out if any changes happen to any of your systems. You will have a record of those changes. Okay, and it saves time by automating, right? If you have to do it manually, it will take a lot of time, but by automating, you write the code once and you apply for many computers, right? That's how you are going to save time. So yeah, if you have huge infrastructure, and this will help you, okay, not only for one or two systems. And when your infra is containing hundreds or thousands of computers, you write the code once and you use it for same hundreds or thousands of computers. Yeah. How do you do this? So we have in any software industry, there are some certain process we have to follow. Okay. So what is the configuration and how do you regulate that? And how do you ensure that your configuration is in accordance with the compliance? Okay. And that will also be, I mean, you can take care of those process. You can effectively implement that process with the help of this configuration management tools. Okay. For example, uh, if you are aware of this Center for Internet Security, FIPS compliant, PCC compliant, there are some regulatory boards by any government which you need to follow, and your systems have to be aligned with that. Your organization has to comply with that rules and regulations. So these tools will also ensure, right? So for example, my SC Linux should be disabled. So how do you ensure? That is a configuration, right? So you make sure that, okay, that value is always disabled. So you go and execute a program, that program will check if that value is disabled or not. If it is not disabled, it will go and apply that. That is how you ensure how your system should behave. If someone forgets to revert or accidentally enable that value, but you can always run some checks and see if that value is not accordance with your expectation, it is not in desired state, you can make sure that that is in desired state by running this program. Okay, that is a too much gyan for you. I don't think you'll understand at this point of time, but yeah. So what is the role of infrastructure? We call it as infrastructure as code. So why we call it as infrastructure as code? Because we are maintaining our infrastructure with the help of code, not with the manual systems administrators. Okay. So what are the roles of this what is the role of this infrastructure as code in DevOps environment? So it is a modern way of managing your configuration item. So an administrator can earlier, if you have a one system administrator, will be given only a portion of the environment or one environment. But with this introduction of with this configuration management tools, then admin can manage multiple environments, right? Because you have everything, it is coded, everything is automated, and it is easy to integrate with the version control system. And now it is considered as an essential component of DevOps, the infrastructure as code. So this is the role of this configuration management tools. And we have, these are the types of configuration management tools I was telling you: Puppet, Chef, Ansible, and SaltStack. Puppet and Chef are Ruby based tools. They are written, there's whatever the configuration you write, that is a Ruby programming language or Ruby DSL. Okay. What do you mean by DSL? It is a wrapper over the native programming language. Ruby is a programming language. On top of that one, you write some wrapper so that again internally that uses Ruby. So that is, we call it as a DSL. So Ruby DSL is used for Puppet and Chef. When it comes to Ansible, it is a Python based configuration management tool. And whereas Puppet and Chef, they are agent based configuration management tools. That means we have to manage your infrastructure, any server, you need to install a Chef agent or Puppet agent on your client machine, okay, which you are going to manage. But whereas in Ansible, you don't need to install anything. Just if you have a SSH connection enabled for this thing, by default, you have to log into any computer, will be enabling SSH connection. So you need to run install any external software, or you don't need to. There is no computing power wasted for this Ansible. That's where Ansible is so popular. Okay. This SaltStack is also a Python-based configuration management tool. Just I'm skipping this. This is how it looks like. Okay, I'll give you. It will be having manifest files and modules in Puppet. So something like this. Okay, you wanted to execute apt update. So how do you program it? So you need to put it in exec apt update. Command is this thing. bin apt update get update. This is how someone writes a programming language to execute apt. For example, if you wanted to install Apache 2 package, right? So what is the command? You ensure it is installed. Just you need to mention a string called ensure installed. And if you wanted to make sure Apache 2 is running, so ensure is the thing which will make sure that your specific software or service is up and running, right? So you put ensure is equals running, it will make sure that Apache 2 is running. If you make sure ensure is equals to installed, it will make sure that Apache 2 is installed. Okay. Same thing. For example, if it is MySQL server, ensure installed and MySQL running. Okay. Similarly, this is a very simple, right? So if you have to install a software, or if you wanted to, you don't need to make document all those steps. How to install? You just make sure that you tell it should be installed and it should be running. So how to install, how to start the service in the background, this tool will take care. Okay. So that's how it is very easy. I'll just focus on architecture of the pet. So we have basically two components, Puppet Master and Puppet Agent. So what this Puppet Master will have, that content, what manifests have to be applied for which server, okay, and GUI, how to see the what are the servers that are part of this Puppet Master, or what servers is being managed by Puppet Master, and reporting, okay, and admin and security. All these layers are at Puppet Master. And in order for a Puppet Master to manage any server, what we need to have Puppet agent running on that particular server, and it should be registered with the Puppet Master, so that then only it can manage. Okay, this is mission 1, mission 2, mission 3, right? On all the missions, we have a Puppet agent running, and you can mention in this Puppet Master UI. So on this server, a web server should be installed. On this server, an application server like Tomcat should be installed. On this server, a database server should be installed. So you'll have manifests written for web server, application server, and database server, and those are applied for these missions in the Puppet UI. So that every 30 minutes, the Puppet agent will go and check with the Puppet Master what is the new configuration identified for this thing. Okay, so it will see, okay, I have to run web server, and it will make sure this web server is running. If the web server is already installed and running, it will not do anything. If it is not installed, then it will go and install. So that is what we call it as a desired state. Desired state is, so you have to have this web server installed and web server is running. That's it. If it is already installed and running, it will do anything. It will not do anything. And if it is not running, it will go and ensure that it is installed and running. That is the concept of any of these configuration management. Not only Puppet, Chef, Ansible also works in the same. So what is the model, how in which this works, right? So you're always not the Puppet server pushes this thing. Only Puppet agent will go and check whether anything is there for this Puppet agent or not. Okay. So Chef is also a similar architecture like Puppet. Here also we have 3 components. Okay. One additional component came into picture, that is a Chef development kit, where you write your Ansible Chef cookbooks. We call it as a cookbook. Cookbook contains recipes. How our normal, this is a kitchen terminology. Okay, in our kitchen, what we'll be having if someone is a cook is doing something, right? So she will go through, refer through cookbook. That cookbook contains a lot collection of recipes, right? A recipe contains some set of instructions. You wanted to make coffee, what are the set of instructions? If you wanted to make a chicken curry, what are the set of instructions? You wanted to make a biryani, what are the set of instructions? So all this just separate recipes. Each recipe will have set of instructions. And if you combine all these recipes, and you can publish a cookbook. Okay, so that cookbook is nothing but set of softwares that you wanted to install in a specific server. You can collect, combine the recipes into a specific role. Here, that role, if you apply to any Chef client, then it will make sure that all the recipes which are there in that specific role, it will execute in the sequential order. Okay, for example, a recipe is you install Java. Another recipe is you install a Jenkins, right? You wanted to install Java followed by Jenkins. You can add in that role Java plus Jenkins. right? So first it will install Java, then it will install Jenkins. So that's how you can assign. So where this cookbooks will be stored, cookbooks, run list, policies, everything will be stored in the chef server, right? And the chef client will contact chef server and it will see what is the configuration identified for this specific chef client. Okay, this is my JFrog server. In that case, what it will go and it will identify what is configured for this server. Okay, so as you know, if you have to install JFrog, right, you need to have a Java recipe and JFrog recipe, so that you will go and add for this server in its run list what is that Java and JFrog, so that it will go and collect all those recipes and follow the instructions mentioned in that run list. Okay, that is first it will install Java, then it will install JFrog. If it is a Jenkins server, it will install Java, then it's a Jenkins server. So that's how it works. So where all these cookbooks are developed on a workstation. We call it as a workstation. So in that workstation, you will develop all the recipes and cookbooks, and you upload those recipes and cookbooks to chef server, so that chef server will have all these cookbooks available in the chef server, so chef clients can download. You can directly manage the chef client from workstation also. If you wanted to apply any cookbook to or any recipe to any client, you can do it through programmatically on workstation. Okay, so this is the chef architecture, but still this is also we are not going to learn. At high level I gave you chef architecture. Okay, and on both these cases, chef and puppet, you need an agent to be installed, right? Here chef client needs to be installed. In our previous example, puppet agent needs to be installed. You have a master, you have a client concept here, server and client concept here. There are also puppet master and puppet agent concept here. There. Okay. And both these concepts works on a pull mechanism. What do you mean by push mechanism and a pull mechanism? If the server initiates the communication, then we call it as a push mechanism. If the client initiates the communication, then we call it as a pull mechanism. Clear? Guys, you know,
Yes.
so here server is not going to push anything to client. So client itself is asking server, what is there for me, right? So in that, what is the advantage of this thing? Because communication is initiated through client, and the client gets the data and it will perform on its own. During that time, there is no load on server. Okay. And whereas in push mechanism, load will be there on server, because server makes sure that for which server, what needs to be pushed, so that entire thing is maintained in the server. So that is the thin processing and thick processing, right? So in this case, is a thin processing. That means load is less on server. So you can manage huge number of servers, hundreds and thousands, even 1,000 servers also the load is same. 100 servers also the load is same. 2 servers also the load is same, because the processing is happening at client side, not at the server side. That is, we call it as a pull mechanism. Clients are pulling, not server is pushing. Okay. So, but whereas when it comes to Ansible, this works on a push mechanism. Okay, Ansible server pushes because there is no agent installed on clients, so it has to establish an SSH connection and issue the commands. Okay, that's where Ansible is a. I mean, there is lot of advantages, but the load is on Ansible server, because we are eliminating the installation of agent on the client machines. Okay. These are some introduction about this Ansible. It is a Python-based open source configuration management tool. It manages both Windows and Linux systems. Okay, it was launched in 2012, but it is acquired by Red Hat. Now it is the Red Hat Ansible. Okay, so but it is, when it comes to learning curve, when it comes to, if you wanted to learn Chef and Puppet, that's bit easy, but Ansible is little bit slow, but it is very powerful. Okay. You need to, you have only two components. One is Ansible controller and Ansible master, and the nodes which you are going to manage. So there is no specific language is needed. It can be, I mean, here, there you have um, recipes, right? So recipes and manifest. Here we call it as a YAML file. You need to write your playbooks. Here we call it as a playbook. There we call it as a cookbook in Chef. Here we call it as a playbook. Okay. A play is a simple collection of tasks, something like recipe. Playbook is collection of this plays. Okay. And play is a collection of tasks. So this is the architecture of an Ansible. You have Ansible controller, and this Ansible controller will have you can manage any servers. If you have web servers, you have database servers, you have application servers, everything you need to connect to SSH, execute the respective playbook commands. So for web servers, we'll be having a playbook. For database server, maybe we have a playbook. I mean, this is a generic term, but for any software you wanted to install, you can write a playbook and you use that playbook to install the software. Okay. These playbooks you can maintain in the version control system, so that Ansible can pull the playbooks from version control system and apply those playbooks onto the respective target missions. So how do you install? Okay, you have a Ubuntu mission. These are the instructions. So we go ahead and do it. Also, I have some more terminology. I'll follow you through this thing. This is yeah. So these are the important terms used in Ansible. Ansible master is this one. Ansible master or control node. Okay, and module is basically a similar set of commands you meant to execute on the client side. I mean, if you wanted to combine some set of instructions where you wanted to execute on a specific computer, then you combine that into a concept called module. Okay, and the task is nothing but a single instruction. For example, download a file is a task, install a file is a task, create a user is a task. Okay, that is what we call as a task. Okay, and play is the execution of a playbook. What do you mean by a playbook? Playbook is collection of these tasks, way of organizing tasks and the related files. We call it as a playbook. Okay, what do you mean by fact? Fact is nothing but any information about any variable. Okay, for example, what is the architecture? That is a fact. Operating system is a fact. Version is a fact. So all these variables, right, what you are going to use or what you are going to refer, we call it as a fact. Okay, or meta information or information about the system or various items is a fact. What do you mean by an inventory? Inventory is nothing but what are all the servers that are being managed by this Ansible master. It's called an inventory. Inventory is nothing but list of computers. Okay. Handler is nothing but it's a, you have some event, right? If on completion of that event you wanted to notify something. Okay. For example, when you can start a service, if the software is installed successfully, then only you can start a service. Without software being installed, can you start the service? No, right? So you can have a handler on software installation task. If the software is completed, then you invoke the handler so that it will go and start the service. If the service software installation is failed, you don't invoke it. So handler is something which you can notify so that if this particular task is completed, then you inform another task so that it will execute. Okay. So these are some of the terminology you need to remember, but anyhow, you will experience this during the learning of a playbook. Yeah, so this is Ansible orchestration engine or Ansible server, where you have inventory, where you have modules, plugins, APIs. Inventory is nothing but list of hosts and some networking, and also Ansible users, right? So where this Ansible entire data is managed, that is in the CMDB. So what servers it can manage? This Ansible can be installed in a public cloud or private cloud, right? You can write playbooks and you can upload into the Ansible server. This is another flavor of Ansible architecture. Okay. Now I'll take a machine and try to install Ansible. Do I have one? Go to the 10 minutes. I'll stop for a minute. I'll check my
So Ali, like for working with the tool, should we start from tomorrow?
I'll show you the installation of Ansible. Okay.
Okay.
But so what I'm thinking is the next class would be very wait a minute.